Some series to integral calculus. Some series to integral calculus. Certainly, I am going to publish some publication on some series and integral calculus. Can we do summation of a series through integral calculus? Generally, people, I've seen it. You see anywhere how people achieve summation of a series. Means the way they achieve, okay, it is something that hard to believe that it is that difficult. Hard to believe it is that difficult. It is extremely difficult if someone is trying to get the summation of a series. Sometimes no one would understand how it is. I have seen it. Okay, it will go for one pages, two pages, three pages, and then in one or two, three line only, people generally they start becoming out of the focus. Can we use integral calculus? Can we use can we use integral calculus? Can we use integral calculus to get the summation of the series? Summation of the series. What summation of series you want? Anyone would ask. What summation of series you want? Okay, I'm saying let's calculate summation of series is 1 plus 1.5 plus 2 plus 2.5 plus 3 plus 3.5 plus 4 plus 4.5 plus 5 plus 5.5 like that up to 100. Can someone calculate it? Okay, I can tell you what it is. What it is. I know 1 plus 2 plus 3 plus 4 plus 5 up to 10. What it is? N into n plus 1 by 2. Okay, 10, if you want to add 1 to 10, then n into n plus 1 by 2. I know it very well. Okay, what is n? N is 10. 10 into 11 by 2, what do you mean? It will come as 55? Yeah, it will come as 55. I know. Okay, then what about 1 plus 1.5? 1 plus 1.5 plus 2 plus 2.5 plus 3 plus 3.5 like that up to 10. Multiply by 2. Simple. You doubled it, right? Earlier there were 10 instances. Now there are 20 instances, more or less. Multiply by 2. Tell me exact. It will be like that only. We'll try it. I am not running you. We'll try it. Okay. Multiply by 2. Okay. Then it will come around 110. Yeah, 110. Tell me exact value. Yeah, consider this is an exact value. Who is stopping you to who is stopping you to not consider it as exact value? Okay, consider this as exact value. Okay, thank you very much. Okay, now let's proceed. What we can do now? Gentleman is saying that it will be double of it, means n into n plus 1 by 2, multiply by 2, n into n plus 1. That will come as 110. Okay, let's proceed now. Okay, now can someone calculate it? Can someone can really calculate it? How much it will come? 1 plus 1.5 plus 2 plus 2.5 or something like that. If someone is very mischievous, if someone is very mischievous, he will say, now you calculate 1 plus 1 plus 1, 1, I don't know what it a mathematical term is. 1 and then write 1 by 3. 1 plus 1 by 3. Makes sense? 1 plus 1 plus and then 1 plus 1 by 3 plus 1 plus 2 by 3 plus 2, means between 1 and 2 I am dividing it into two parts, 1 by 3, 2 by 3 and then 2. Then 2 plus 1 by 3, 2 plus 2 by 3 and 3 like that up to 10 you tell me. Multiply by 3. Okay, 1 plus 1.1 plus 1.2 plus 1.3 plus 1.4 like that up to 10. Multiply by 10. Okay, what about if I start with 0.1, start with 0? 0.1 plus 0.2 plus 0.3 plus 0.4 up to 10.9. Then multiply by 11, multiply by 10, 0 to 11. Okay, here calculus comes into the picture. If so many things are there, then there is no ready-made formula for it, and it will be extremely tedious. And like that, there can be many. I have just talked about x only. Fx equal to x. The actual formula for this is fx equal to x. When x is one and a half, then fx is one and a half. Means now we are talking about calculus. Otherwise, it is in numerical science only. So we will go with 1 plus 1 and a half, or 1 plus 1 plus 1 and a half. I'm sorry, 1 plus 1 and a half plus 2 plus 2 and a half plus 3 plus 3 and a half plus 4 plus 4 and a half up to any count 10 or n. That is under question mark now. Can someone really able to solve it? Now let's see from the in from the calculus point of view. Calculus is a science that talks about functions. Okay, calculus works in functions. Okay, so calculus works in function. Let's watch it minutely. 1 plus 1 and a half plus 2 plus 2 and a half. Can someone mold it to calculus? That is the question. Can someone mold it to calculus? Okay, we will start by two technology that we have provided. One is repeated summation and one is successive approximation. Two ways we are trying to get the solution of it. One is repeated summation and one is successive approximation. Both are our way. If you search for repeat successive approximation and repeated addition, you may not get it. What are these? Repeated summation and successive approximation are concerned. If we talk about this, what it is? Okay, let's say I'm giving a question that 1 plus 1 and a half plus 2 plus 3 and a half plus like this. The one of the best solution that we have suggested is divide problem into n different parts. Divide problem into n different parts. If I say 1 plus 1 and a half plus up to 10, up to n, up to n, means there are n counts are there. One count, one and a half, second count, two, third count, two and a half, fourth count, three, fifth count. Like that, we have n count. Let's divide this full summation into n different parts. When first part is 1, second part is one and a half, third part is 2, fourth part is two and a half, like that. Now we will solve only one part and then we will sum it for others or will generalize it for others. Let's solve a part where we have two and a half. What to solve there? Can we think about a generic way I can represent two and a half? Someone would say it x. Say it x. If I say it x, then what about other part? All are x. What are you trying to say? I'm trying to say it is x plus x plus x plus x plus x plus x n times. Okay. If I say that only the numerical, only the number without decimal, the number without decimal like 1, 2, 3, 4, if I call them n, then it is more or less 2n. It is more or less 2n. If I say you have to add it up till 15, up till 15, then will be typically 15 into 2 terms will be there out there. Okay, how much it will be? Means now we have, if I say 15 is n, then 2 into n compartments are there. Each is x. Each is x. Okay, this is how. These are very precious discussions, very precious. Now, this is x-axis. If this is x-axis, this is origin, and x is going like this. At any x, now we have x equal to 1, x equal to 1 and a half, x equal to 2, x equal to 2 and a half, x equal to 3. Like that, x equal to n. I say x equal to n. N is 15 now. Now, if I say what is your value at x equal to 1, then value is 1. X equal to 1 and a half, value is 1 and a half. X equal to 2, value is 2. X equal to 2 and a half, value is 2 and a half, like that. Are you trying to say that there is a slant line like this? Yeah, there is a slant line like this, which angle is 45 degree. As you grow, then at any point x, there is a vertical. At any point x, there is a vertical. Vertical height is same as what is x. This function is fx equal to x. If I take any point x and if I draw a line which hits this line, there is a vertical here. And that vertical is fx or x. Make sense? Are you trying to say that you are adding all the verticals? Yeah, I'm adding all the verticals. At x equal to 1, there is a vertical. X equal to x equal to 1.5, there is a vertical. X equal to 2, there is a vertical. X equal to 2.5, there is a vertical. Like that, I have 2n number of vertical if it is going x equal to n. N is 14, 15, 16, 2n. I have so many verticals. Okay, let's add it. Let's add it. What do you mean by add it? Add it. You're adding all the vertical, right? Where one vertical, first vertical is 1, second is 1.5, third is 2, next is 2.5. Okay, means you are trying to say that if what is everyone? If I talk in algebra, then first is function over x, second is function over x, third is function over x, fourth is function over x, fifth is function over x, like that. Means you are adding function over x number of times. Makes sense? Fx plus fx plus fx plus fx x number of times if I'm adding, it becomes fx plus fx x number of times. Fx function over x into x, where x is how many times you are adding. Okay, then it is fx dx. Fx into x will become fx dx. Limit will come. Where from dx is going? Dx is going from 1. If I say typically this is how it is. So I can say it is going from 0 to 2n, 0 to 2n, where n is whatever non fraction number we are thinking about. N can be 14, 15, 16, 17, which does not have any fraction. Okay, I'm not saying, I'm saying n is not 2.5 or something like that. It is 4, 5, 6. Anyway, if you understand the concept, you can take that out. So it is going to 0 to 2n. It is going to 0 to 2n, where n is the non-decimal number. Fx dx, that is x squared by fx is x, because at any x height is x1, x dx, x squared by 2, x squared by 2. Makes sense? If it is x squared by 2, then how much it will come? Okay, 2n whole square by 2. 2n whole square by 2. Okay, how much it will? 2n whole square by 2. If there n equal to 10, if n equal to 10, then it will go for 20 terms. So 20x square. What? Okay, it is fx dx, x dx, x square by 2. Okay, x square by 2, x is going how much? Okay, x is going, if I say x, it will come as 2n whole square, 4n square by 2, 2n square. It is coming as 2n square only. It will come as 2n square. That may not be perfect solution work, but it is like that. I would say this is how it is. This is called, people, if they understand more, then they can come to better results like this. This is called repeated addition. Finding the solution through repeated addition. Make sense? Finding the solution through repeated addition. Okay. Now we will go with the successive approximation. That will give the exact result. Successive approximation. What is successive approximation? This repeated addition means if I want to add 5, if I want to add 5, consider I want to add 5 7 times, 5 plus 5 plus 5, 7 times, 5 into 7, 5 into x, where x is 7, 5 dx, where dx, 5 dx, it will integrate x to 0 to 7, same result will come. This is what we tried. Fx into x, fx dx, It will go from lower limit to higher limit. Fx is x square by 2, lower limit to higher limit. Someone has to put like this. I believe it is all right. Okay, now this is rough idea someone get that what would be the result. Let's go with, someone will say, I want exact mathematical equation, not rough idea or whatever. Let's go with the successive approximation in integral calculus. What is successive approximation is, this is, consider this is x-axis, and this is the curve we are monitoring now, that is fx equal to x, and we are adding it. What we are trying? Summation, sigma sign, summation x equal to 1. Summation x equal to 1 to n. X equal to 1 to n fx. We are adding summation x equal to 1 to 2n whatsoever, 2n fx, where fx is getting added, or fx. What is fx? I believe fx we can say it as x by 2. Fx is x by 2. Fx is x by 2, or someone can say summation, whatever. I believe it is understandable. That's why we come to integral calculus, where it is perfect. Anyway, summation of x equal to begin to end. Someone can take n or 2n whatsoever. Fx. What is fx? Fx is x, where every time x someone has to increment half. Okay, first x will be 1, then x will be 1.5, 2, 2.5, like that. That I have to sum it. Means if I have x-axis, then x is going, this is very tedious, x is going x equal to 1, 1.5, 2, 2.5, 3. Every half, x is proceeding like that. Every half, x is proceeding like that. Okay, in that fashion, what someone can say, double it. Double it means 1 will become 2, 1.5 will become 3, 2 will become 4, then 2.5 will become like that. So it will start at 2 rather than 1. It will start at 2, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it will go multiplied by 2. Whatever you are ending at. If I am ending at 10, it will go up to 20, 2 to 20. Summation x equal to 2 to n into 2, 20 fx by 2 by 2, or summation x equal to 1 to n fx, but it will go incrementally half, not 1, half whatsoever. This is the scenario. Can be achieved through integral calculus. If I want to achieve through integral calculus never talk about summing the vertical. We want summing of the vertical. Integral calculus talks about summing the, integral calculus talk about purely this, what we are trying now. We have a discrete function called fx equal to x. Fx equal to x is a discrete function. It looks like a straight line, but it is not a continuous line. Rather, it is x equal to 1, it is a height like this. X equal to 1.5, height is like this. X equal to 1, height, x equal to 2, height is this. It is discrete line is there. This is also called point mass function. Point mass function means everywhere the line is different. It is not a continuous line. But if I connect all the top points of each height, then it will form a line, and that line equation is fx equal to x. At any x, you have height fx, that is x only. Makes sense? So this is a discrete formula, fx equal to x. It is not a continuous line. Okay, it is sampled at x equal to 1, x and half, 1, 1.5, 2, 2.5, like that. Consider there is another function called gx. There is another function called gx. Gx is a continuous line. If I say gx dx, if I say I have, this is gx and this is fx, which is not a continuous line. If this is gx dx, if I say gx dx, it will give, calculate area underneath it. Okay, now how many samples I have taken? I have taken sample from 1 Consider 1 to n. 1 to n. I have taken numbers from 1 to n. 1, 1.5, 2, 2.5, 3, 3.5, like that up till n. Okay, how many verticals are there? There are verticals. 2n or 2n minus 1, whatsoever. There are verticals. Okay, let's divide gx. If I say summation of fx, then summation of all the verticals. Okay, let's take any point x here. Any point x here. Then what is the fx at that point? X, same as x. Okay, what is the gx at that point? Gx is a continuous function, arbitrary we have taken. What is gx at that point? Gx at that point. What is fx at that point? Fx at that point. Same thing. Now, but fx is only set of vertical where gx will give the full area. Let's divide this gx into parts. This gx, let's cut into part. How many part you will cut? Wherever I have x equal to 1, draw a vertical line. X equal to 1.5, draw a vertical line. X equal to 2, draw a vertical line. Like that, draw a vertical line at each sampling. And in between two vertical lines, create a sub area, small sub area. Means we have combination of small sub area that forms gx dx. Understand? Now, if I talk about a sub area at x equal to 1, x equal to x, then fx at a height, this height must match whatever sub area we are calculating gx, and then till the next sampling. If this is the sampling, if this is x, then this is next sampling, that is x plus 1 by 2. That is the next sampling point for fx. Between x and x plus 1 by 2, we have a sub area that goes for gx. This sub area should be exactly same as fx. If it is like that, then summation of all sub area is exactly same as what we have summation of all the verticals. Next. Means I'm trying to say, if I take fx at any x equal to x, what we are trying to do? Sigma summation of fx means all the vertical should be same as integral of gx dx from lower limit to higher limit. This is the expression we are thinking of now. Summation fx, sigma of fx, where fx will be added many times in discrete manner, equal to limit gx dx, where gx is a continuous function. Its gx dx will give the area underneath it, and that area should be exactly same as summation of all the verticals. If that is true, then we have divided this area into many parts the way there are verticals here. At x equal to x, I have fx, and that fx must match as gx dx between x to x plus 1. If that matches, then we get idea is to find gx. Let's try now. What is fx? Fx is x. X equal to integration x to x plus 1 gx dx. Means fx equal to gx dx. Gx equal to dfxy by dx. Means 1. We'll try now. 1 dx. Limit is x to x plus 1 by 2. Because if this is x, then next vertical will be at x plus 1 by 2. If this is 2, then next is at 2 plus 1 by 2. So 2 to 1 by 2, this is the sub area we are calculating, and for that we have vertical called x. Next vertical will be x plus 1 by 2. Next vertical will be x plus 1 by 2 plus 1 by 2. For x, what is the vertical height that should match with the gx dx between x and x.5. So fx equal to limit x to x plus 1 and x plus half gx dx. Gx will start with the 1. 1 dx means x and to x and half will be exactly 1 and half. This side we have x, this side we have x, and this side we have 1 by 2 that are not similar. It should be x. So if I divide x by 1 by 2, it will become 2x. 2x means whatever we are doing right now, 1 dx I have to multiply with the 2x. Let's start with the 2x now. 2x integration will be 2x square by 2, x square. X square, I'll put limit from x to x plus 1 by 2. It will become x plus 1 by 2 whole square minus x square. X square will go away. It will become x plus 1 by 4. That will remain here. X plus 1 by 4. Make sense? X plus 1 by 4. And this side we have x, and this side we have x plus 1 by 4. 1 by 4 is extra now. So I will subtract with 1 by 4. I will subtract with 1 by 2 because limit is x plus 1 by 2. It will become 1 by 4. So we'll try now. Extra is 1 by 4. I will subtract. So x, 2x, 2x, 2, 2, 2, 2x. Hope. We'll try again. 2x. Extra was 1 by 4. Let us start with the 1 by 4. Now subtract this side x, this side x plus 1. Let's subtract x minus x plus 1 by 4. That will become minus 1 by 4. 1 minus 1 by 4 is extra. We'll try again. 2x minus 1 by 4. 2x minus 1 by 4. We'll try. 2x minus 1 by 4. If I do integration, it will become x square minus 1 by 4x. X, if I set limit x to x plus 1 by 2, x square will become x plus 1 by 4. This is what we have already seen. It becomes x plus 1 by 4 minus x plus 1 by 4 minus 1 by 4x. X will become x plus 1 by 2 minus x 1 by 2 minus 1 by 8. It will become minus 1 by 8. Minus 1 by 8. And this side we have x plus 1 by 4. X is matchable. So minus 1 by 8 we are getting. Instead we should have got 1 by 4, not 1 by 8. So we will try with 1 by 2. We tried with 1 by 4. We try with 1 by 2. Make sense? Okay, we'll try again. Because it is successive approximation. 2x minus 1 by 2. 2x minus 1 by 2. If people are very avid, then they can say 2 and x minus 1 by 4. This is what you should have tried earlier. If 1 by 4 was coming extra, then you should have tried, because if you see this side it was x and this side it was x plus 1 by 4. So x, all right, 1 by 4 is extra. So in x you have to subtract 1 by 4. So we had 2x, now it will 2x minus 1 by 4. It will become 2x minus 1 by 2. So that is better. We'll try again. 2x will become 2x square by 2. X. 2x square minus 1 by 2x. Limit is x to x plus 1 by 2. First we'll settle down as x. First we'll settle down as x plus 1 by 4. Next is minus 1 by 2x. X will become 1 by 2. So 1 by 4, 1, it will become x. X is exactly x. It is completely all right now. Now we have formula. That is 2x minus 1 by 2. This is gx. And if I integrate gx, it will give the result. Now let's integrate. 2x minus 1 by 2. It will become x square minus 1 by 2x. 2x minus 1 by 2. Integration is x square minus 1 by 2 x. Okay, what is the limit now? Let's see the limit. We are talking about section, right? Consider that we are trying to calculate 1, 1.5 and 2. There are 3 lines. Okay, 1 is 1, 1 is 1.5 and 1 is 2. Okay, if I have to add 3 lines, then we have gx. And gx will be, we are dividing gx into 3 parts. Because 3 verticals are there. Each vertical will be 1 subsection in gx. Make sense? Okay, if it is 1, then gx limit is this height 1, then that is equal to the sub area in the gx, and that sub area is from 1 to 1.5. Next sub area is from 1.5 to 2. Third sub area, because there has to be 3 sub area. If I'm adding 3 vertical lines, 1 plus 1.5 plus 2. If I'm adding 3 vertical lines, then 3 vertical line will become 3 sub area. 3 sub area. First sub area is from 1 to 1.5. Second is between 1.5 and 2. And third is between 2 and 2.5. That is the third area. Okay, in that fashion, I have to take integration 1 to 2 and half. Okay, not 1 to 2, even though I am adding 1 plus 1 and half plus 2. But third section will come as 2 to 2 and half. So now net integration will be 1 to 2 and half. I believe it is all right. 1 to 2, 1 to 2 and half. Let's place it here. X square minus 1 by 2. X square minus 1 by 2x. Okay, what is your net formula that you have brought in? What is the net formula that you have brought in? Net formula we have brought in is x square minus 1 by 2x. This is the formula we have brought in, where limit will go from 1 to x plus 1 by 2. If I am adding till x, what is your x? X can be anything, anything. 5 and half, 6, 6. If I say my x is up till 6 and half, I have to add 1 plus 1 and a half plus 2 and half, half like that up to 6 and half. Then integration limit will go from 1 to 6 and half plus 1. Last section will be beyond 6 and half. So our limit will go from 1 to x plus 1 by 2. Okay, if it is 1 and a half, 2, then it will go from 1 to 2 and half. So it is 1 to x plus half, that limit will go. Now we have integration is x square minus 1 by 2x. Let's do with the 1 and 2 and half. That will be easy to measure. Actual addition is 1, 1 and a half and 2. How much it will come? 3, 4, 4 and a half. It will come as 4 and a half. It should come as 4 and a half here also. 1 to 2 and a half integration limit is there. And net integration is coming x square minus 1 by 2x. Let's put 2 and a half here. So 2 and a half whole square will become 6.25. This is 2 and a half. 25 whole square 6.25 minus 2 and a half by 2. Minus 2 and a half by 2. That will come as 1.25. 6.25 minus 1.25 will be 5. 5. 5 will keep minus, and then 1 we will keep here. 1 to 1. 1 square is 1 minus 1 by 2. 1 half minus half. 5 minus half, 4 and a half. I believe it is all right. Okay, someone will say, you try between 1, 2 and 1, 1 and a half, 2, 2 and a half, 3. I believe it is easy. Okay, then you try. Then it limit will go 1 to or 2 up to 2 and a half. 1, 1 and a half, 2 and 2 and a half. Now you do. The limit will go from 1 to 2 and a half plus 1 plus half. 3 up to 3. Now try now. 3 square 9 minus 1 by 2 into 3, 1.5. That will come as 7.5. 7.5 we keep it. Then lower limit will go there, that is 1. 1 we have seen already. 1 minus half, 0.5. It will subtract 0.5. 7.5 minus 0.5 is 7. It is 7. Is it really 7? Let's try now. 1 plus 1 and a half plus 2 is 4 and a half. Plus 2 and a half, that is 7 only. Amazing, mind blowing. Let's devise the actual formula. Then actual formula will be 1 to x plus half, and integration coming is x square minus 1 by 2x. First we'll put x and half. So it will become x and half whole square. It will be x square plus x plus 1 by 4 minus x by 2. Instead of x, I have to put x and half. Okay, x and half. So it will become x and half by 2. It will become minus x by 2 minus 1 by 4 minus x by 2 minus x by 2 minus 1 by 4. I think so. Minus 1 by 4. X plus 1 and half by 2. This side minus is there. Minus x by 2 plus 1 minus 1 by 4. This side 1 by 4, 1 by 4 will go away. This side x and this side we have minus x by 2. Minus x by 2. Then it will become x by 2. So it will become x square minus plus x by 2. This is what we are getting with the upper limit. Lower limit is 1. That I have to subtract. Let's settle it down. X square minus x by 2. 1, if I keep it, then it will come as 0.51. 1 by 2. 1 by 2. Okay, so it will come as x square plus x by 2 plus 1 by 2, minus 1 by 2. This is what the solution is, what I can do. It is like that only. Means it will come as I'm sorry, huh? Too much confusion. We'll try again. Okay, I think all right. X square plus x by 2 minus 1 by 2, x square plus x minus 1 by 2, or 2x square. 2, it is coming as x square. Okay, what we can do? Or x square plus x minus 1 by 2. X square plus, and a numerator is x minus 1, denominator is 2. Let's try again. Okay, what is your x? What is your x? Okay, x is 2. X is 2. Means 1 and 1 and a half and 2. This I have to add. That should come as 4 and a half. X square will come 4 square. 2 square, 4, plus x minus 1. X is 2. 2, correct. 4 and a half. Okay, let's take x as 3. X as 3, then it will be 9 plus 3 minus 1, 2 by 1. It will come as 10. 10. We'll try 1 plus 2 and a half plus 2 is 4 and a half, 2 and a half, 7 plus 3, 10. Let's try 1 plus up till 9 and a half. Then 9 and a half whole square plus 9 and a half minus 1 by 2, whatever it comes. Can anyone imagine it? It is like that. Someone can search it. What is 1 plus 1 and a half like that? Now someone can say, okay, understood. Can you try starting from 0.5? You started with 1, right? Start from 0.5, no problem. Then limit you have to do. Whatever formula we have received, that is integration of 2x minus 1 by 2. That is x square minus 1 by 2x. Limit I have to start from 0.5 to x plus 0.5. That's it. The last one will be x plus 0.5. That's it. And place it, and that will be the formula. This is called power of integral calculus. Sir Isaac Newton had invented integral calculus. Means calculating multiplication of two items through area way, and that area way brought up to this location, this position. Okay, now there is another way to calculate it. Someone would say, if there are 3 verticals, then you took right side, 1 to 1.5, 1.5 to 2, and 2.5. 3 some area you took, because you need to calculate 3 vertical. What about left side if you take? If you take left side, then 2 will be the end. Then 1.5 to 2 one section, 1 to 1.5 another section, and then half to 1 is another section. Means fx equal to limit earlier limit was x to x plus half. Now limit will be x minus half to x. Makes sense? If I try left side, right now we are trying right side, creating area subsection of gx on right side. Let's take left side. Then the integration will be x minus half to x, gx dx. Okay, we'll try gx with the x. Earlier we started with 1. Let's try with the x. Then it will be x square by 2. X square by 2. Limit is x minus 1 by 2 to x. It will be x square by 2 minus x minus 1 by 2 whole square by 2. That will come as x square plus x square minus x plus 1 by 4 by 2. I think so. Okay, this is starting with the x. Someone can try now. Someone can proceed. It is very difficult. Anyway, let's take out 1 by 2. Then we have 1 by 2 outside, and inside we have x square minus x square plus 2x minus 1 by 4. X square will go away. Now we have x minus 1 by 4. Makes sense? Outside 1 by 2 is there. It should be equal to x, that is left side. Okay, means we have now x by 2, x by 2 and x by 2 minus some change is there. Here we have x by 2, here we have x, means I have to multiply by 2 and then start again. If I do for 2x, then 2x square by 2, 2 will go away, x square. Now if I set x square from x minus 1 by 2 to x, then it will become x square minus x square plus x minus 1 by 4. Then x square will go away, x will remain. That is what we want. But extra what we are getting is minus 1 by 4. So I have to add 1 by 4 there. Means if I add 1 by 4, we have 2 and in bracket x plus 1 by 4. It will become 2x plus 1 by 2. We try again. 2x plus 1 by 2. That will become x square plus 1 by 2x. Limit is x minus half to x. Okay, x square will become x minus 1 by 4, the way it came last time. X minus 1 by 4. X is matching, no problem. Minus 1 by 4. Okay, this is for x square term plus 1 by 2. 1 by 2 x. X is x minus x plus 1 by 2. It will come as minus 1 by 2 into 1 by 2 minus 1 by 4. It will come as up. Yeah, it will come as minus 1 by 4. And this side we have plus 1 by 4. Plus 1 by 4. I think so. Plus 1 by 4. Okay. So more or less it will become neutral only. Over. Scenario is over. So net solution is 2x plus 1 by 2. We'll try again. 2x plus 1 by 2. If I integrate, it becomes x square plus 1 by 2x. Okay, limit is x minus half to x. If I put x, then it becomes x square plus 1 by 2x minus. And then I have to keep x minus 1 by 2 here. Minus and in bracket. In bracket what it is? X square plus 1 by 2. I have to push now x minus 1 by 2. X square will become x square minus x. X square minus x. Okay. Hope it is very difficult. Person can try. X square minus, hope. We have x square plus 1 by 2x. And then in x I am replacing with x minus 1 by 2. X square minus x plus 1 by 4. That will come. Okay, instead of x square. Plus 1 by 2x. 1 by 2x. Hope. I'll do it again. I will try again. Okay, we have 2x plus 1 by 2. Integration is x square plus 1 by 2. X square plus 1 by 2. Okay, let's set x square plus 1 by 2. If I keep x, that is top. If I keep x, it becomes x square plus 1 by 2x. That I keep left side. X square plus 1 by 2x minus, and then in bracket we have to settle x square as x minus 1 by 2. That will come as 1 by 2 is outside. That will come as x square by x square minus x plus 1 by 4 plus 1 by 2x. So for plus 1 by 2x, x will become now x minus 1 by 2. So it will become, okay, 1 by 2, too much confusion. People can try. What we want is x square plus 1 by 2x. Limit is x minus 1 by 2 to x. That's why I took easier path first. We'll try again. X square plus 1 by 2x is coming from the top limit minus lower limit. Lower limit is x square minus x plus 1 by 4 plus 1 by 2x. 1 by 2 and x is x minus 1 by 2. X by 2 minus 1 by 4. Okay, 1 by 4, God's sake, it went away. Okay, x by 2 will remain. Here we have minus x. Here we have minus x. Minus x, and 1 by 4 went away. Minus x plus x by 2. It will come as minus x by 2. Minus x by 2. And here we have x square plus 1 by 2x. Okay, and then we have minus 1. Only x square is remaining. Is it really true? I don't know. Only x square is remaining. Okay, only x square is remaining. Okay, if that is the case, let's try now. If I want to add 1 plus 1 and a half and 2, then limit I have to start from 0.5 to x minus 1 by 2 to x. Let's try. 0.5 to 2, 0.5 to 2, and then we have 0.5 to 2, and we have x square plus 1 by 2x. That is the actual x square. X up, too much. Oh, that up, too much confusion. Too much confusion. Okay, actually the concept was that integration of 2x plus 1 by 2 from x minus 1 by 2 to x should come as x. I remember this. This is the actual concept. Then only we will say we have come to a solution. We'll try again. Gx we are saying 2x plus 1 by 2. X square plus 1 by 2. From x minus 1 by 2 to x. This should come as only x. Only x. If it is coming as only x, then we have met the criteria. Okay, now x square plus 1 by 2, 1 by 2x. Okay, if I keep top limit, then it is x square plus 1 by 2x minus lower limit. If I place lower limit, that is x minus 1 by 2, then we have x square plus 1 by 2x. There I have to push this. It will become x square minus 2x plus 1 by 4. Okay, plus 1 by 2 in x we have to set x minus 1 by 2. It will become x by 2 minus 1 by 4. 1 by 4, 1 by 4 goes away. It is x by 2. We have x square x minus x plus x by 2. It will become x square minus x by 2. Outside minus is there. Minus x square plus x by 2. Outside waiting but x square plus 1 by 2x. And here we have minus x square plus 1 by 2x. Total will become x only. Means it fulfills what we want. So this is perfect solution. 2 integration of gx is 2x plus 1. I'm really sweating now. Dx is 2x plus 1 by 2. 2x plus 1 by 2. Let's find out from 1 to 2 and half. 1 to 2 and 1 to 2. 1 plus 1 and half plus 2. If I try to find, the limitation will start 1 below. It will start from 0.5. If we have taken left side, it will start from 0.5. 0.5 to 1 subsection on gx. If I take gx, then 0.5 to 1 subsection, 1 to 1 and half another subsection, 1 and half to 2 another subsection. So 0.5 to 2, where gx is 2x plus 1 by 2. It will become x square plus 1 by 2 x. 0.5 to 2. If I set 2, it becomes 4 plus half, 4 and half. It is becoming 4 and half. It is becoming here only. It is becoming 4 and half. Okay, let's try another. Set the limit of 0.5. X square plus 1 by 2 x. If I set 0.5, x square will become 1 by 4. 1 by 4, 1 by 4 plus 1 by 2x, 1 by 4. It will become half. Half. 4 and half minus half, 4. This is not the solution. 1 plus 1 and half plus 2 is 4 and half, not 4. We'll try again. We have found solution at 2x plus 1 by 2. Integration with x square plus 1 by 2x. Limit is, we are saying 0.5 to 2. 1 less, half less it will be. 0.5 to 2 is the limit. Let's put 2 now. 2 square. X square means 2 square. 2 square is 4 plus plus x by 2. X is 2. Oh, it is 1. 4 plus 1, 5. 5 minus half, 4 and a half. Perfect. Now, it is readers, it is people who are watching, it is their responsibility to bring in what will be the exact solution. Exact solution is gx dx from x and half to x. Sorry, 0.5 to x. Earlier it was x to, earlier it was 1 to x plus zero point 0.5. Now it is 0.5 to x. 2, 2x plus 1 by 2 integration, that is dx, that will come as x square plus x by 2. Limit is half 1 by 2 to x. If someone is able to find, will find. Top is x square plus x by 2. If I set the bottom negative, then if I take 1 by 2, then x square 1 by 2 is 1 by 4 plus 1 by 4. 1 by 2 if it goes, then it is 1 by 4 plus x by 2 1 by 4, that is 1 by 2 minus 1 by 2, means x square plus x by 2 minus 1. Oh, it came same. What we calculated earlier with the positive side and negative side both are same. X square plus x minus 1 by 2. Same. Okay, this is the way, but this has innumerous possibility in a term that from anything, we will try one more example next time. Anything to anything. Someone will say, you tried with 1 plus plus plus, right? Start with 0.5. Who is stopping you? No, 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 I don't want 0.5. Start with minus 2.5 and then go on. Anywhere, anything. Just think about gx dx and limit which area subsection you are taking. And then you do like this. We will do more session on it till it becomes really a kind of something that habituated people, it will come in their habit. This is called power of integral calculus. Okay, we will publish at least an article on this, not book, or we'll try to publish a book, because this is going to solve a very, very difficult problem. This is not a repeated summation. Someone is saying 1 and 1.5 and 2 and 2.5. This is not a repeated summation that I can repeat. Or everything is different. But dividing problem into n part, bringing to an algebraic equation, and then solving it. Amazing, mind blowing. Please do not mind supporting us. +91 is the India country code 9483160610 is a telephone number. +91 is the India country code 9483160610 is a telephone number. People can try searching it anywhere. What is the actual algebraic formula? Is it the same? X square plus and then x minus 1 divided by 2.